This is the first lecture of week 9 and we'll discuss internal and external validity. So let's step back and take a broader look at the regression. Is there a systematic way to assess regression studies? We know the strength of multiple regression, but what are some pitfalls? We will list the most common reasons that multiple regression estimates based on observational data can result in biased estimates of the causal effect of interest. In the test score application, let's try to address these threats as best as we can and assess what threats remain. After all this work, what have you learned about the effect of test scores of class size reductions? So in this lecture, we're going to talk about the concept of internal and external validity. Internal validity means that the statistical inferences about causal effects are valid for the population being studied. Whereas external validity is that the statistical inference that we found can be generalized from the population that we studied to the population of interest. So we'll talk more about both of these concepts. So we'll start off with external validity. So assessing the threats to external validity requires detailed knowledge and judgments on a case-by-case basis. So for instance, how much can we generalize the class size effect on test score result from K through 8 California school districts in 1999? The similar the population and the setting is to our original study, the more likely that we can generalize. For instance, can we generalize the result from K through 8 California school districts in 1999 to K through 8 school districts in Mexico in 1999? Or what about college students instead of K through 8 students in California in 1999? You need to know a lot about these places and this population to be able to generalize our result to these different settings. What about different time periods? So can we generalize our finding from 1999 to findings what can happen in California in 2020? If it has different legal requirements, for instance, California had a different types of special education program in 1999 versus 2020. This may actually invalidate our result that we found in 1999, and we may not be able to generalize what we found into what could have happened in California in 2020. So even though the population may be the same, that we look at the same K through 8 California school districts, because of the different environment in 1999 versus 2020, we may not be able to generalize what we found into different years. So in this case, the external validity is threatened. Also, maybe it's likely that we can generalize what we found in California to rest of US. And we can have a stronger case for this if we have other studies that support this in other states. So for instance, if you look at Massachusetts school districts K through 8 in 1999 and you find the same or similar result as the one you found looking at California school districts, then now you have a stronger evidence that you may be able to generalize what you found in California to the whole US. So that's one of the ways that you can test the external validity of the study that or the result that you have. So a threat to internal validity is more of a serious issue because if you don't have an internal validity, that means that the statistical inference about the causal effects are actually invalid for the population that you studied. So There are 5 different threats to the internal validity that we're going to look at in this lecture. The first is omitted variable bias that we have looked at before using the single linear regression model. The second is the wrong functional form. The third is errors and variable bias. The fourth is sample selection bias. And the last one is simultaneous causality bias. So any one of these bias or issue would make the error term correlated with your regressor, which means that your OLS estimate will be biased and inconsistent. And what do I mean by that it's biased? It means that the estimate that you obtained is different from the true population coefficient. And what it means to be inconsistent is that even with the large sample size, this bias doesn't go away. So it's a problem when we're trying to estimate the true coefficient, population coefficient. So we'll talk more about each of these threats in the next lecture.